So now that you've seen the server, let's go ahead and talk about the client. So the client is obviously the side that's going to be doing the work. We saw earlier that in this case, the client is actually called by the test program. And the test program, through the use of these annotations, knows how to automatically launch the microservice or the folder application or the whatever you want to call that thing, monolithic application in this case. And it also knows how to then have the client call requests on that service. So let's go take a look at the client and we'll see what it does. So here's the folder client. And as you'll see, this is the part that makes the request to the folder application and the controller and so on, and then gets the results back and does stuff to them. Now, this particular application uses, this particular client uses auto wiring to connect up the folder client with a folder proxy. And you'll see folder proxy is right here in the client folder. And its purpose in life is to shield the client from the details of using the web programming model. So this client, for the most part, really just looks like it's making normal requests as if these objects were co-located. And it's using the proxy to actually make the request go across to the server, to the service. So let's go ahead and take a look and see how this works. So in this particular case, we've got the main entry point is either called run tests, which will run tests that are either mostly local. And then there's also another thing called run remote tests, which definitely runs things remotely. And I'll talk about why it's mostly remote. Mostly local. So let's take a look at the mostly local stuff. So we parameterize this by whether we want things to run concurrently or sequentially. And then the first thing we do for the mostly local stuff is we create a folder from the remote server. So this is actually going to go over to the server, get the entire directory structure, which is rather large, as you can see. It's got thousands of entries in it. And it'll then cache that locally here on the client. And then the rest of the methods here all work off of that cached version to apply various operations, like count the number of words that match, count the number of entries, count the number of lines, get documents that contain the search words, and so on and so forth. And so we run all those tests, and they all run locally once we've cached the contents of the folder in our client. So how do we do that? We call create folder. Create folder is just this helper method. And what this does is it goes and it calls the proxy. And it says, hey, please make me a remote folder. Please get me a remote folder. And so we're going to take a look and see how that works. You'll notice that all these operations are timed. And I do that so that when we're all done at the end, I can see how long everything took to run. And this is what's produced here. It prints out how long all the different operations took in order to do their thing. And the run timer method is carefully designed so it doesn't really obtrusively corrupt too much stuff. You can kind of still get an inkling of what's going on here while we're timing stuff. So let's take a look at the create remote folder method. And you'll see that all these methods in the proxy pretty much look the same. And that's, again, by design. So one thing you'll note is that down here we have a REST template. And this is auto-wired. And if you go over to the common package and look at the components file, you'll see we have a factory method that's defined as a bean. And the bean is another Spring annotation. And this basically says, if you want a new REST template, here's how to create it. So what we do here is we make a new REST template, and then we tell that REST template, I want the base URL to be whatever's encoded here in this concept, which is localhost : 8081. Now, of course, the production system would be a lot smarter than this. You wouldn't use localhost, but this is just illustrating how you can encode things for testing purposes and then encapsulate all those details using a bean, which is then auto-wired together using Spring's dependency injection framework. And in fact, I think I probably actually should put that a little bit higher up here. And let's, oops. Oh. We will futz with this later. Let me get this up here and hopefully there we go. That's a better place for it. And this actually doesn't have to be here anymore. We had it as a utility class at one point, but we don't need it like that. Okay, so now we're going to go ahead and define a bunch of string constants that will have URIs to create various kinds of entities. So in this case, this is the create folder URI, and you can see it's got the folders kind of namespace. It's got this root dir, which is /works, which is the kind of the database entry that we want. And then we've got the name of the request endpoint handling method, which is called create folder. That's what's going to be used to map by Spring over here to the create folder guy there. So we create a bunch of these things. I just make constants. It's a little easier to see what's going on. We don't have to do it that way. There's other ways to do it. So here's create remote folder. Create remote folder uses a very useful method I wrote called make get request. You'll see what it does in a second. And it takes the REST template as the first parameter, and then we encode the URL. And what this does is it's going to take that create URI string we had earlier, which is /folder/work/create folder. And it's then also going to add a query parameter, which is going to be whether or not we want this thing to run concurrently. It's going to build that and then make a string out of it. And that's what's going to be passed as the string that will be combined with that base URL that we had in the REST template in order to make the GET request that will be sent over to the server, where it will then be mapped by Spring onto the folder controller's create folder method. And then the last thing we do is we indicate what type we want the return value to be, which in this case is going to be a durant. So let's go take a look at make get request. Here's what make get request is. It's just a little helper method I wrote to make things a little cleaner. So you can see it takes the REST template. It makes a call on the REST template called get for entity, passing in that URL that we built, passing in the class that we passed in, and then what comes back is going to be an entity that we get the body of. It's going to be a response entity, and then we go ahead and get its body, which returns it as type T. So this is just a nice little generic helper class to avoid having to litter our application code with all this other gobbledygook. So that's how we make a remote folder, and that basically just sends it over to the server. We get back the contents as a durant, and you can see that's what gets returned here. And very, very clean, very, very simple. And I think you'll also agree that by using this proxy design pattern, the rest of the code doesn't care that we're using all this HTTP gobbledygook in the proxy. It hides that from all the things that are going on. So on the client side, once we've got that folder, then we go ahead and we make these calls. Notice now we're making the same calls we made on the server, except now we're doing them on the client side on the cached folder, recursively defined composite folder structure we got back from the server. So we were sharing these operations on either the client or the server, so they can be done either place. In this case, we've cached the data, so we paid the cost of bringing it over, but then henceforth everything is much faster because it's all just method calls with no extra remote procedure calls. The other client method here is the one that runs the remote tests. And all of these calls all use that proxy in order to send a request over to the server to do the request remotely. So for example, in this case, we're going to search for a word remotely. We're going to count the number of entries in the hierarchy remotely. We're going to count the number of lines in that composite recursive hierarchy remotely. We're going to search for all the documents that match completable future or whatever. I think I should probably make that more abstract, call it search word. And we do that remotely and so on and so forth. So all of these calls are all taking place through the proxy. So they're all going over to the server side. And I won't walk through all the examples here, but I'll just touch on a couple of them. They're all basically the same thing. Let's take a look at this one because it's a little bit more interesting. So this is the get documents proxy method. And you can see it takes the string that we're searching for and whether we want to search concurrently or in sequentially. And this time, we're going to do something different. We're going to use a different helper method I wrote called make get request list. And what this is going to do is it's going to go ahead and basically take the REST template, encode the URL from the get documents URI constant, which is /folder/work/get documents. Then we're going to pass in the word that we're looking for as a query parameter and the Boolean, whether it's true or false, whether it's concurrent or not. Similar basic idea, just a few more. There's an extra query parameter put in there. But notice what we want as the return value here is going to be an array of durends. And that is what gets sent back from the get documents method over here in the controller. If you take a look at get documents, just lurking here somewhere, here it is. You can see we return a list of durends. And a list actually comes back as an array. So at the low level, it comes back as an array. And here's how I wrote my little helper method. This uses a different method on REST template called exchange. Earlier, we had used get for entity. Now we're using exchange. And exchange is a little bit broader because you give it the URL, but then you say whether you want to do a get request or a post request or a put request or a delete request or so on. And you pass in the class, which in this case is an array. And what we get back here is something called a response entity. So we get back a response entity, which is basically a response entity to an array of type T, which in this case is durends. And then we say, hey, response entity, get your body, please. And then that'll come back as an array and convert that array into a list. So we end up getting back a list, in this case, an immutable list of documents that contain the contents that match that word that was passed in earlier when we'd been in the proxy where we passed in the word and encoded the word. And of course, even further up, that was passed into the proxy by just a good old method call. So once again, you're seeing a lot of really cool patterns here. You're seeing the broker pattern very clearly. That's what the controller model is implementing of Spring. It's the broker pattern. You can see the use of the proxy pattern here where we're making calls on a proxy, thereby shielding the bulk of the client from all the details of how things work to communicate using GET requests. We're also leveraging a lot of kind of helper methods that come out of the box from Spring, and in order to be able to encapsulate this as cleanly as possible so we don't have to do a whole lot of work on ourselves, a lot of work on our end in order to be able to do this. So it just makes the whole system very clean and very simple and as streamlined and canonical as possible. Now, as you'll see in the example that we use for the assignment 2, we go even one step further and we use essentially a dependency injection framework called retrofit, which hides all of this stuff from you. So you don't even have to write the proxies. So if you're willing to go even further and use dependency injection mechanisms and basically automated proxy engines, you can get away with even having to write proxies at all, which is another great thing you could do. I didn't bother going quite that far in this case, but you could. And that is another illustration of the power of kind of combining all these different mechanisms. So that is essentially the client. Like I said before, the client is called by the test program. All of this stuff automatically launches the server and the controller, which then forwards to the service. And so those are the bulk of the pieces that are put together in order to make the whole application be a nice client-server model.